Welcome to the Level 3 video on the modulus function. Today we're going to be following on from the Level 2 video and solving some more challenging modulus function questions. So let's jump straight in and do an example. Find the maximum negative integer value, and we'll say n, such that the following, so the modulus of 2n minus 15 divided by n squared plus 4n is less than 1. So we have to find the maximum negative integer such that this is true. And the solution to this is, first of all, let's rewrite this equation as minus 1 is less than 2n minus 15 divided by n squared plus 4n is less than 1. And we can go ahead and multiply by n squared plus 4n. So we get minus n squared minus 4n is less than 2n minus 15, which is less than n squared plus 4n. And now we have to solve these two separately. So we have to solve minus n squared minus 4n is less than 2n minus 15, which is the first inequality, and 2n minus 15 is less than n squared plus 4n. And it turns out that the second inequality here actually has complex values for n, but we're looking for a real integer value, so we can't use the second inequality. So we're just concerned with the first one. Minus n squared minus 4n is less than 2n minus 15. And when we go ahead and solve this, we get n is less than minus 3 minus 2 times root 3, and n is greater than minus 3 plus 2 root 6. And if when you solve this, if you think of it just as a quadratic and solve it, and you end up with two numbers, so this is approximately minus 7.8989 something something something, and this is approximately 1.8989, and you might think, is n greater than this, is n less than this, so is n in this interval or outside the interval? And the best thing you can do is just try a value that's inside or outside. So let's try n equals minus 20 and substitute it into the inequality. So we're going to have minus minus 20 squared minus 4 times minus 20 is less than 2 times minus 20, which is minus 15, and this will give us minus 320 is less than 55, and this is of course true, so we know that n equals 20 is going to be in our solution range. So we actually want, on our graph, we can illustrate this much better. We've got our two values, minus 7.89 and 1.89 approximately. So this is the negative one and this is the positive one, and because minus 20 is outside this region, we want all points that are outside of these regions. So we've got minus 7.89 blah 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 and 1.89 in that direction. And to remind us of the question, we're finding the maximum negative integer. So we want to exclude all the positive integers, and we're just looking at the negative ones, and we want the biggest one that's actually outside of this region. So that's going to be -8. So if we took -9, that would work, but -8 is actually bigger, and we're looking for the maximum. And if we took -7, that would be inside this region, which is not valid, and therefore it wouldn't work. So the answer is -8. Then moving on, let's talk about another quick example. Find the minimum positive integer n such that the modulus of n squared, the modulus of 7n squared plus 3n minus 1 divided by n squared plus 2n is less than 1. And our solution to this first of all, we have to rewrite this as -1 is less than 7n squared plus 3n minus 1 divided by n squared plus 2n is less than 1, and then multiply by the denominator of what we have inside the modulus. So we multiply by the denominator here, so n squared plus 2n so we're going to have minus n squared minus 2n is less than 7n squared plus 3n minus 1 is less than n squared plus 2n. Now we want to solve these two separately. So first of all, we want to solve minus n squared minus 2n is less than 7n squared plus 3n minus 1, and that gives us, simplifying this, the following is true: the modulus of 7n squared plus 3n minus 1 divided by n squared plus 2n, and that's all minus 7, is less than 1. And our solution to this, is we have to first of all rewrite as -1 is less than 7n squared plus 3n minus 1 over n squared plus 2n minus 7 is less than 1. And then multiply by n squared plus 2n, because it's our denominator here. So we're going to have minus n squared minus 2n is less than 7n squared plus 3n minus 1 minus 7 times n squared plus 2n is less than n squared plus 2n. Now we have to solve both bits of this inequality, and it's probably best to split these up. So we have to solve minus n squared minus 2n is less than 7n squared plus 3n minus 1 minus 7n squared plus 2n, and we also have to solve 7n squared plus 3n minus 1 minus 7 times n squared plus 2n is less than n squared plus 2n. And simplifying these, we get n squared plus 13n plus 7 is greater than 0, and the second one gives us n squared minus 9n minus 17 is greater than 0. Okay, now I'm going to split these up in colours and you'll see why in a minute. So n squared plus 13n plus 17 is less than 0. Gives us the following ranges for n. So n wants to be greater than minus infinity, but less than negative a half times 13 plus root of 165. And it wants to be, n wants to be greater than a half times minus 13 plus root of 165, but less than infinity. Okay, and in green, let's do the other interval. So the other quadratic inequality gives us n squared minus 9n minus 17. It's greater than 0, and this gives us that n again wants to be greater than negative infinity, but less than a half of 9 minus root of 85, and n wants to be greater than a half of 9 plus roots of 85, but less than infinity. Okay, and let's sketch out exactly what this means. Okay, so our blue interval is going to be here and here. Our blue interval is going to be here and here, and our green interval is here and here, and we're looking outside these intervals. But we can actually forget these two arrows because both of the intervals overlap, and we actually just want to look less than the smallest value of the green interval and greater than the biggest value of the blue interval. And the original question said we want to find the minimum positive integer, so we look just at the positive integers, so we're looking just past the blue interval, and this value here is approximately 9.10977. So that is root of 165 minus 13. So the minimum positive integer that satisfies that is going to be the next integer out of this blue region. So it's going to be n is 10. So it's going to be that n equals 10, because n equals 9 will not satisfy the equation because it's in the region, but n equals 10 will. Thanks very much for listening.